Hey, what's going on, guys? GoMegaGains here. In this video I'd like to introduce the comparison of perf test results for three CNC engines. So we would have a look at the performance of Fairy Stockfish, my engine, Wukong CNC written in JavaScript, and Chameleon. So Fairy Stockfish and Chameleon are both written in C++ and literally are the derivatives of the Stockfish engine itself. And quite surprisingly, it's really confusing, but that's really true that actually both mode generators are very slow, and it's really hard to figure out why exactly that is happening. I actually already had a conversation with Fabian Fischer, the author of Fairy Stockfish, and he explained me what was some reasons behind it. But anyway, first of all, I just really want to demonstrate you this, and then we'll try to go for a bit of an explanations. And again, like I'm so tempted, I just can't. I can hold myself, and I really want to say already that at very least, based on this results, it's already enough for me to start an attempt to start my own attempt of creating a CNC Stockfish fork, which I already did, and I'm now already writing code along with the Stockfish's code, believe it or not. Probably, yeah, for those who's interested, I'll probably demonstrate that at the very end of the video, and probably the next one would be covering some very basics of what I've learned about the Stockfish's code infrastructure so far, and how in particular am I gonna be kind of adding new code that regards to Chinese chess CNC. Okay, guys. So without further ado, let's actually go for some tests. So here I want to open the terminal where the build for Fairy Stockfish is already available, and here is the command that Fabian gave me to test the perft for okay, sorry, it's a little bit of an unfortunate thing. So just open terminal in the wrong place. I'm sorry for this. So let's try again. Open terminal, paste. Come on. Oh, sorry. What am I doing? I just need to save Fairy Stockfish. Okay, so, but we need the depth 5, like this. Well, bearing in mind the fact that the video recording software is now working, it's going slightly slower compared to how it goes when video recording software is not working actually. But anyway, so this is really so damn slow, to say at least. And we'll now see the time spent to make perft at depth 5 for Chinese chess as it goes in Fairy Stockfish. Okay, so it takes total time 39,804 milliseconds. So remember this number. I'm not gonna be closing the window. So the next thing to have a look at, so the next thing I want to run the perf test for this exactly the same starting position. So we are within the starting position. It's not printed, but trust me, that is it. That is it. And here is the node search. So this would be the same in all the engines, obviously. So if I simply say node UCI.js, this would start my Wukong CNC in UCI mode, and just say position start boss to initialize the initial position, and then I just say perf 5. And here is the performance test for my JavaScript engine, and you just without having a look at the total time, you just see that visually it really seems like about the same speed. Well, actually it goes slightly slower, but still I think, you know, like this is really impressive that the JavaScript engine which is array based, by the way, which is the key point here, it's really like almost on the speed like the C++ engine that plays the same variant. And when I initially saw this, I was really confused, to say at least. I was really confused. So let's have a look how it goes, and the total time as well. So as you probably might have guessed already, that what am I going to be doing is actually try to create an array-based mode generator for Stockfish in order to make it play Chinese chess. Okay, so here is the time spent for with my engine, but this is the JavaScript engine, guys. So you just imagine, so it would be, I don't know, 5 times faster at very least if it would be written in C++, and that's exactly this stuff that I'm doing, that I'm currently working on. So I think this is really impressive, isn't it? Okay, now we just quit from here, and one last thing to show you guys is I just really want to go for Chameleon. So CNC Engines Chameleon, developed by Wilbert Li. And here I've already altered the source code a little bit, so to run the perf test out of the box, if I just run this Chameleon, it would start the perf test. But Chameleon seems to be working even slower compared to Wukong, believe it or not. So even visually, this seems to be a little bit slower. Well, at least I had really slower results for Chameleon compared to Wukong. But guys, this is the C++ stuff. Can you believe it? So I know that both authors, like Fabian and Wilbert, actually were using they reused the bitboard stuff from original Stockfish, and probably that is kind of like a slowdown. But I was reading an issue open on Fairy Stockfish, and actually Wilbert Li, the author of Chameleon, stated there that with array-based representation it would be faster, and now I really believe this, which it might sound a little bit strange, but you just see the perf results. So by the time it's searching, I just really want to go to, so let's go for Fairy Stockfish. Okay, so I'm going to the issues, and here is the issue, I believe here is the issue. So bitboard speed is extremely slow. So this is Wilbert Li, author of Chameleon. Much slower than array board, which should be everything a ledger board should consider, but no one actually handles it. So this is the state. This is the statement actually. However, when I had a personal conversation via email with Wilbert, he actually said that bitboards are faster. I don't know, maybe he meant this for international Western chess. I don't know, but just to give you an idea, that where is Chameleon? Yeah, this is Chameleon, right? So you just compare this number. So it's slower than in Wukong. Can you believe this, guys? Chameleon, a C++ engine, so you see like the number of nodes is the same, but it's slower compared to Wukong, which is JavaScript. Can you believe this? This is so weird, right? It's really hard to believe this is possible, but it's true. So you see like it's slower, but it's in C++. How on earth is that possible, right? So here are the perf results, basically. So I just open the third one, and just to showcase them all together, literally. So we have 1, 2, and 3 here. So we have Chameleon is the slowest one, then goes Wukong, here it is, and finally Fairy Stockfish. Fairy Stockfish is the fastest so far. So this is it, guys. Yeah, it's really something to think about, I believe. So let's close the results, and at the very end, I just want, if only I find that issue that I have opened and already closed on GitHub today. I'm just wondering where. It's not even active there. I thought it would have been my activity. I don't know. Oh my god, how can I access the closed issue on GitHub? The one that I've closed on my own. Okay, if I just go to issues, let's say is closed. Okay, this is it. So here is the question I asked. So I said, like, it's strange that the perft speed is about equal for my engine, which is written in JavaScript, and the Fairy Stockfish. And here is the response by Fabian. So the main reason for this slowdown is the overhead due to the generalizations of the support of many piece types and roles. Specialized engines for specific games contain optimizations that rely on particular assumptions about the roles of the game. For instance, in the case of Stockfish, the code assumes that all non-pawn pieces have symmetrical moves. An example that a piece moving from A to B can also move from B to A. So all but pawns, which is broken by piece types like the horse. So to not overly complicate the code with a lot of special cases, I removed several of such optimizations. So he just removed several of optimizations. I'm not sure if this is the case of Chameleon as well. Well, might be. And at the same time needed to add additional logic for special rules of some variant. This significantly slows down the move generation and particularly the move validation, since the checking for attacks on the king is very expensive when not being able to exploit specific assumptions about the rules. This is a known issue, but I would like to mitigate it. So this is a link to another issue, and already implemented some improvements recently for games with very moderate changes compared to chess, since the profiling and optimization is very time intensive, and I unfortunately cannot work on that much on this topic. Contributions on this are of course very welcome. So this slowdowns cause a performance loss of around from 100 to 200 elo points, and this really correlates with the results I had when back in the day. I've improved the speed of the move generator of my international Western chess engine Wukong, and one of my subscribers actually helped me doing that. And well, I was considering that the elo gain from that optimization was around 100 elo points, and this was even more when I was playing new versus old version. But the eventual CCRL testing only showed about around 700 elo points gained for the latest version of International Western Chess Engine Wukong JS that I've developed. So yeah, guys. This is kind of it. And when I just ran these tests, I really decided that it's kind of like worth trying to create actually an array-based mode generator and connect it to Stockfish's search, and actually that gonna go in this way. Well, obviously, I can't probably ever imagine how hard it would be in the future. Because I'm not really I probably don't yet understand where in particular do I step in, but anyway, I already started coding, and that's the CodeMonkey's approach. You just start coding and then see what happens. And in the next video, I will introduce what I've did so far. Well, really nothing much to demonstrate, but I would rather want to share some sort of CodeMonkey's way of exploring Stockfish's code base, which is probably horribly wrong, but it kind of works, at least at the moment. And you know, like for me, it's a real, it's really really an amazing experience, to be honest. And I really wanted to share this with you guys. So don't miss the next video on chess programming channel. So there I'll demonstrate how in particular I've just started, how I started working with the Stockfish's code base, and what am I supposed to be doing in order to replace the entire move generator to actually make Stockfish generate moves for Chinese chess and not for international Western chess as it does by default. Okay, guys, so this is it from my side. Thanks for watching. Until the next time, and take care.